All right, Chapter 3 of the Private Oral Exam Guide. Chapter 3, this is determining performance and limitations. Chapter 3, Section B, weight and balance. On 3-11, define the following. Empty weight. The airframe, engine, and all items of operating equipment that have fixed locations and are permanently installed in the aircraft includes hydraulic fluid, unusable fuel, and undrainable oil. Gross weight. The maximum allowable weight of both the airplane and its contents. Useful load. The weight of the pilot, co-pilot, passengers, baggage, usable fuel, and drainable oil. Arm. The horizontal distance in inches from the reference datum line to the center of gravity of an item. And the moment. The product of the weight of an item multiplied by its arm. Moments are expressed in pound inches. Center of gravity, the point about which an aircraft would balance if it were possible to suspend it at that point, expressed in inches from the datum. Datum, an imaginary vertical plane or line from which all measurements of arm are taken, established by the manufacturer. All right, so useful load, pretty good. The weight of a pilot, co-pilot, passengers, baggage, usable fuel, and drainable oil, which would add to the gross weight the maximum allowable weight of both the airplane and its contents. What basic equation is used in all weight and balance problems to find the center of gravity location of an airplane and or its components? So that would be weight times arm equals the moment. By rearranging of this equation to the forms, weight will equal the moment divided by the arm. The arm is the center of gravity, equals the total moment divided by the total weight. With any two known values, the third value can be found. Remember, weight times arm equals moment. Wham! Weight times arm equals moment. All right. What performance characteristics will be adversely affected when an aircraft has been overloaded? If it's been overloaded, you'll have a higher takeoff speed. You'll have a longer takeoff run. You have a reduced rate and angle of climb. You have a lower maximum altitude. You have a shorter range. You have a reduced cruising speed. You have reduced maneuverability. You have a higher stalling speed. You have a higher landing speed, which will give you a longer landing roll, and you have excessive weight on the nose wheel. What effect does a forward center of gravity have on an aircraft's flight characteristics? You have a higher stall speed. Stalling angle of attack is reached at a higher speed due to increased wing loading. You have a slower cruise speed. Increased drag, greater angle of attack is required to maintain altitude. More stable. The center of gravity is farther forward from the center of pressure, which increases longitudinal stability. Greater back elevator pressure required. The longer takeoff roll, higher approach speeds, and problems with landing flare because you can't get the nose up. What effect does a rearward center of gravity have on an aircraft's flight characteristics? You have lower stall speeds. Yeah, that's good. Less wing loading. You have a higher cruise speed, reduced drag, smaller angle of attack is required to maintain altitude. Less stable. Stall and spin recovery more difficult. The center of gravity is closer to the center of pressure, causing longitudinal instability. Won't be able to get your nose down. What are the standard weights assumed for the following when calculating weight and balance problems? Crew and passengers. Figuring crew and passengers are 1,770 pounds each. Gasoline is 6 pounds US per gallon. Oil 7.5 pounds per gallon. And water is 8.35 pounds per gallon. Aircraft performance. What are some of the main elements of aircraft performance? Takeoff and landing distance, rate of climb, ceiling, payload, range, speed, and fuel economy. What factors affect the performance of an aircraft during takeoffs and landings? Air density, which is the density altitude, the surface wind, runway surface, upslope or downslope of the runway, and the weight. What effect does wind have on an aircraft performance? Takeoff. A headwind will increase the airplane's performance by shortening the takeoff distance and increasing the angle of climb. However, a tailwind will decrease the performance by increasing the takeoff distance and reducing the angle of climb. The decrease in airplane performance must be carefully considered by the pilot before a downwind takeoff is attempted. Landing. A headwind will increase airplane performance by steepening the approach angle and reducing the landing distance. A tailwind will decrease performance by decreasing the approach angle and increasing the landing distance. Again, the pilot must take the wind into consideration prior to landing. Cruise flight. Winds aloft have somewhat an opposite effect on airplane performance. A headwind will decrease performance by reducing ground speed, which in turn increases the fuel requirement for the flight. A tailwind will increase performance by increasing the ground speed, which in turn reduces the fuel requirement for flight. How does weight affect takeoff and landing performance? Increased gross weight can have a significant effect on takeoff performance. You have higher liftoff speed, greater mass to accelerate, which will be a slower acceleration, increased retarding force, drag and ground friction, and longer takeoff distance. The effect of gross weight on a landing distance is that the airplane will require greater speed to support the airplane at the landing angle of attack and lift coefficient, resulting in an increased landing distance. What effect does an increase in density altitude have on takeoff and landing performance? An increase in density altitude results in increased takeoff distance, greater takeoff airspeed required, reduced rate of climb, decreased thrust and reduced acceleration, increased true airspeed on approach and landing, same indicated airspeed, increased landing roll distance. That was the effects of density altitude have on takeoff and landing. Increase in density altitude. Define the term density altitude. Density altitude is pressure altitude corrected for non-standard temperature. Under standard atmospheric condition, air at each level in the atmosphere has a specific density, and under standard conditions, pressure altitude and density altitude identify the same level. Therefore, density altitude is the vertical distance above sea level in the standard atmosphere at which a given density is found. How does air density affect aircraft performance? The density of the air has a direct effect on lift produced by the wings, the power output by the engine, propeller efficiency, and drag forces. What factors affect air density? Altitude. The higher the altitude, the less dense the air. Temperature. The warmer the air, the less dense it is. Humidity. More humid air is less dense. Number 9. How does temperature, altitude, and humidity affect density altitude? A. Density altitude will increase low L air density when one or more of the following occurs: high air temperatures, high altitude, and high humidity. Density altitude will decrease high air density when one of the more of the following occurs: low air temperature, low altitude, and low humidity. Good. Knowing the following speeds for your airplane. Cool. VSO is the stall speed and landing configuration. Calibrated power off stalling speed is the minimum steady flight speed at which the airplane is controllable in the landing configuration. The VSI. Stall speed clean or in a specified configuration. So calibrated power off stalling speed or the minimum steady flight speed at which the airplane is controllable in a specific configuration. VY. Best rate of climb speed. The calibrated airspeed at which the airplane will obtain the maximum increase in altitude per unit of time. The best rate of climb speed normally decreases slightly with altitude. Vx, the best angle of climb speed, the calibrated airspeed at which the airplane will obtain the highest altitude in a given horizontal distance. The best angle of climb speed normally increases with altitude. maximum landing gear extension speed, VLE. The maximum calibrated airspeed at which the airplane can be safely flown with the landing gear extended. This is a problem involving stability and controllability. VLO, maximum landing gear operation speed. The maximum calibrated airspeed at which the landing gear can be safely extended or retracted. This is a problem involving air loads imposed on the operating mechanisms during extension or retraction of the gear. VFE, maximum flap extension speed. The highest calibrated airspeed permissible with the wing flaps in a prescribed extended position. This is a problem involving the air loads imposed on the structure of the flaps. VA, maneuvering speed. The calibrated design maneuvering airspeed. This is the maximum speed at which the limit load can be imposed, either by gust or full deflection of the control surfaces, without causing structural damage. VNO, normal operating speed. The maximum calibrated airspeed for normal operations or the maximum structural cruise speed. This is the speed above which exceeding the limit load factor may cause permanent deformation of the airplane structure. VNE, never exceed speed. Calibrated airspeed which should never be exceeded. If flight is attempted above this speed, structural damage or structural failure may result. What information can you obtain from the following charts? Takeoff charts. These allow you to compute the takeoff distance of your airplane with no flaps or with a specific flap configuration. You can also compute distances for a no-flap takeoff over a 50-foot obstacle scenario as well as with flaps over a 50-foot obstacle. The takeoff distance chart provides the various airplane weights, altitudes, temperatures, winds, and obstacle heights. Fuel, time, and distance to climb chart. This chart will give the fuel amount used during the climb, the time it will take to accomplish the climb, and the ground distance that will be covered during the climb. To use this chart, obtain the information for the departing airport and for the cruise altitude. Cruise and range performance chart. This is designed to give true airspeed, fuel consumption, endurance in hours, and range in miles as specific cruise configurations. Crosswind and headwind component chart. This allows for figuring the headwind and crosswind component for any given wind direction and velocity. Landing charts provide normal landing distances as well as landing distances over a 50-foot obstacles. Stall speed performance charts. These are designed to give an understanding of the speed at which the airplane will stall in a given configuration. Will typically take into account the angle of a bank, the position of the gear and flaps, and throttle position. Define the term pressure altitude and state why it is important. Pressure altitude. The altitude indicated when the altimeter setting window barometric scale is adjusted to 2992. This is the altitude above the standard datum plane in the theoretical plane where air pressure corrected for 50 degrees Celsius equals 29.92. Pressure altitude is used to compute density altitude, true airspeed, and other performance data. The following questions are designed to provide pilots with general review of the basic information they should know about the specific airplane before taking a flight check or review. What is the normal climb out speed? What is the best rate of climb speed? What is the best angle of climb speed? What is the maximum flaps extended speed? What is the maximum gear extension speed? What's the stall speed in normal landing configuration? What is the stall speed in a clean configuration? What is the normal approach to land speed? What is maneuvering speed? What is redline speed? What engine out glide speed will give you maximum range? What is the make and horsepower of the engine? How many usable gallons of fuel can you carry? Where are the fuel tanks located and what are their capacities? Where are the fuel vents for your aircraft? What is the octane rating of the fuel used by your aircraft? Where are the fuel sumps located in your aircraft? When should you drain them? What are the minimum and maximum oil capacities? What weight of oil is being used? What is the maximum oil temperature and pressure? Is the landing gear fixed, manual, hydraulic, or electrical? Electric. If retractable, what is the backup system for lowering the gear? What are the nose wheel turning limitations for your aircraft? What is the maximum allowable demonstrated crosswind component for the aircraft? How many people will this aircraft carry safely with a full fuel load? What is the maximum allowable weight the aircraft can carry with baggage in the baggage compartment? What takeoff distance required if takeoff were made from a sea level pressure altitude? What is your maximum allowable useful load? Solve a weight and balance problem for the flight you plan to make with one passenger at 170 pounds. Does your load fall within the weight and balance envelope? What is a final gross weight? How much fuel can be carried? How much baggage can be carried with full fuel? Know the function of the various types of antenna on your aircraft.